Okay, sorry about that, guys. My video cut out. So I connected my points with a smooth curve. Now here's what I want you to see. Remember how I told you that when x was 0, y was undefined? What it means is that when x is 0, there is no y value. This curve is never going to touch this line. It's never going to touch that axis, and it's never going to touch this axis. It's impossible because it's undefined. So here is what an inverse variation looks like when it's graphed. Pretty cool, huh? All right, one more problem, you guys, and then I'm going to turn you over to a couple of practice problems here. And there's only 2 practice problems I'd like for you to do if you have time at the end of class. But before we do that, let's make a real-world application. It's not truck transportation. That's what it is in your book, but the problem that Mrs. Fairbank chose is a different problem that has to do with bike riding. Okay, has to do with bike riding. So in an inverse variation, if x2 is greater than x1, and x1, y1 equals x2, y2, then y2 has to be less than y2 has to be less than y1. That's just basic understanding for the way an inverse variation works. We talked about that already, right? That if x increases, y has to decrease. That's what we're looking at here. So let's put that into a real world application. I'm going to do my work down here, and you're welcome to do that as well. And we've got Maria riding her bike. And we understand that there's going to be an inverse relationship here. If she rides her bike at a rate of 12 miles per hour, it will take her 1 3/4 hours to reach her destination. How long will it take if she travels at a rate of 18 miles per hour? So I'm going to use this formula, x1, y1 equals x2, y2. My inverse variation relationship. If she rides her bike at 12 miles per hour, that's my x1, 12 miles per hour. It's going to take her 1 3/4 hours to reach her destination. That's my y1. Okay, so 12 times 1.75. That's 1 3/4. How long will it take if she travels at a rate of 18 miles per hour? There's my next x value, this one right here, 18 miles an hour. How long will it take? That's my y2 value, and I don't know what it is. That's the question. What is this? Thankfully, this is pretty easy math for us to do at this point, right? We just need to multiply 12 by 1.75. So if you've got your calculator, or you want to do this in your head, either way, or you can do it on paper, right? Either one, I'm going to do it on my calculator, and I get 12 times 1.75 equals 21. Okay, 12 times 1.75 equals 21, and this becomes 18y. Now, in order to solve for y, I'm going to divide by 18. Notice I didn't subtract it from here because it's attached to the variable through multiplication. In order to undo multiplication, I have to use the inverse operation. The opposite operation for multiplication is division, all right? So I divided by 18, and when I do 21 divided by 18, the answer that I get is 1.16 with a rep of 10, so I'm going to say 1.1, I'm just going to round 1.17 hours. All right, simple enough, hopefully, just a matter of putting the right numbers in the right place in the right equation. All right, you guys, I'm going to turn you over to Mrs. Bryden. If you've got time left in class, please take out your dry erase boards and complete D and E here for lesson 64. You might notice if you look at the practice problems that we've already done A and B here in our notes, as well as C. So only D and E remain. So get to work on these, guys, and once you've got the right answers, it'll probably be time to be released. Your homework for lesson 64 is due at our next class period.